video is about quantum computers. So, why quantum computers in the first place? By 2025 or probably 2025, transistors will be so small that it'll generate so much heat that the standard silicon technology might eventually collapse. So, to understand this is that energy or electrons flow through a transistor or the wire or something. And as the wire gets smaller, so does the bridge or the let's just say there's like a bunch of soldiers, okay? Just say there's about 100 soldiers guarding the bridge, or a bridge, to not let somebody pass through. As that bridge becomes smaller, so does the guards. Okay, so that's not a problem. But what if that bridge becomes too small that it's smaller than the person itself? Like it's like having let's just say your little sister's guarding you from going to your bedroom. You could easily jump over her. That's basically what it is with electrons. The bridge becomes so small that's basically not even a bridge anymore because the electron can just jump over to the other side. That's why we have quantum computers. A quantum computer is a machine that performs calculations based on the law of quantum mechanics. Quantum mechanics basically states that one thing can be two things at once, but this only applies to things so small that we can't even see them, smaller than electrons. So they use something called quantum entanglement and superposition. So quantum computing operations were executed on a very small number of qubits. A qubit is just represent one or any quantum superposition. So it could be 1, 0, like a normal computer, it's either 1 or 0. But in quantum computers, it can be 1, 0, or 1 and 0 at the same time. Basically, what this means is that, let's just say, there are two people in a movie. Let's just say there are people in the line for a movie, okay? And one ticket is for one person. But quantum mechanics breaks this rule. Because let's just say we have a really, really big t shirt, and under that t shirt are two people. And those two people could pass into the movie studio with just one ticket, right? Because they're eventually just one fat person. Same with this. They break basically the laws of physics because they're able to be two people at once. This means that they can pay less to go through the movie theater. So the two people can pay less to go to the movie theater. Same with this. We have less electricity to sneak in two values at the same time. And we can manipulate it based on algorithms. So yeah, that's basically what it is. So it's the arbitrary superposition of second two n different states. That's basically what it is. The sphere is called the Bloch sphere, and it provides a useful mean to visualize the state of one single qubit. So quantum computers are what we call 3D computers because the qubit is usually in 3D. Well, in computers, it's just 2D shape because the 3D shape is what allows it to converge into different forms or one of zeros because it could be a qubit by being straight. Like let's just say this two part caves in to become a one, or this part and this part cave in to become a zero. Just an example. That's not what's going to happen, but just an example. So the physical implementation of a qubit could use the two energy levels of an atom. An exit state representing 1 and a ground state representing 0. So basically, there can be an electron and not an electron at the same time. This is what allows it to pass through the bridge. Like in earlier as my earlier example, like you could just jump over your little sister because the bridge is so small. Same with electrons. After the bridge becomes too small, they just jump over the bridge. But this is not with quantum computers. Quantum computers have qubits, and they can basically have one electron and no electrons at the same time. So we don't know how that works, but that's just how it is. So let's just say it passes through the detector to see when it's a 1 or a 0. How can we retrieve information properly if we don't even know if it's a 1 or 0? That's basically what I said. These detectors act as the guards. So, like I said, pretend these are the people who are going to check your tickets. And these are the two people. Like I said, these two people can sneak in at one person and go through their separate ways, right? This guy can go to another movie and this guy could go to another movie. Same with this. But this actually values us because we could sneak in more information by doing this. You know what I mean? So this means that we could have algorithms way faster. So if it takes a computer 1 minute to do something, it'll take a quantum computer like 5 seconds to do the same thing, while spending less energy because we don't have to pay more. We don't have to pay more to get more. We can pay less to get more. Same with quantum computers. Two people sneaking in as one person, they go through their separate ways. So yes, like I said, multiple computations simultaneously, because just because of the extra third value, this adds to more people, or I mean, more algorithms or more things. So this is where algorithms kick in, because it can be a 1 or a 0 at the same time. This allows it to be two things at once until we say so. So we could basically have it something exist and not exist at the same time. So let's just say there's a picture of your mom, right? And but you don't have your picture of your mom stored, but the quantum or the qubit knows it's a mom and a dad at the same time. So let's just say this asks for the picture of your mom and your dad, this whole thing. A normal computer would just have this stored as your mom and this one stored as your dad. But in a quantum computer, your mom and your dad can be stored in the same, qubits, because it can be a 1 or 0 at the same time. So a single qubit can be forced into a state of superposition. This is basically the algorithm to see if it's a 1 or a 0, and when we want it to be a 1 and when we don't want it to be a 0. So yeah, this is a 0 and this is a 1 when there's two electrons. So there's 1 and a 0 at the same time. So these are usually the gates. So what a gate is that it's basically the movie theater guy. So the movie theater guy is the guy who's going to check your tickets. You know what I mean? So that's what these are. Just different people who are going to check if you want it to be a 1 or a 0. They control if it's going to be a 1 or if it's going to be 0. So let's just say you have a quantum computer and it's 50 years into the future and you want a picture of your mom. So you want a picture of your mom, and these gates choose the timing to become a 1 or a 0 and pulls out the information. So yeah, that's